Every single day, more than 100,000 flights take to the skies, weaving a complex web across continents and oceans. From the first light of dawn to the quiet hours of midnight, the world's airspace is alive with movement, connecting cities, families, and businesses in ways that were once unimaginable. These flights carry millions of people, each with their own stories, hopes, and destinations, safely through the skies day after day. The sheer scale of this operation is breathtaking, yet for most travelers the experience feels routine, almost effortless. But this seamless journey isn't a matter of luck or chance. It's the product of decades of relentless innovation, rigorous training, and a single overriding principle: safety above all else. Behind every flight is a vast network of professionals, engineers, pilots, air traffic controllers, and maintenance crews, working tirelessly to ensure that every detail is checked and every risk is managed. Today's airliners are true marvels of engineering, equipped with layers of advanced technology. From sophisticated avionics and flight control systems to powerful engines and resilient materials, every component is designed to anticipate, detect, and prevent nearly every conceivable risk. The calm and comfort you feel in the passenger cabin is a testament to this hidden architecture of safety. While you read, sleep, or gaze out the window, countless systems are quietly at work, monitoring, adjusting, and protecting. For every potential problem, there are multiple pre-planned solutions ready to go. Redundancy is built into every critical system, ensuring that if one component fails, another is ready to take over instantly. Pilots and crew train for every imaginable scenario, so they're always prepared to respond with precision and calm. Statistically, flying is far safer than driving a car, riding a bike, or even spending time at home. The odds are overwhelmingly in your favor, thanks to the aviation industry's unwavering commitment to safety and continuous improvement. Every incident, no matter how minor, is meticulously analyzed by teams of experts. Black boxes are studied, data is reviewed, and lessons are learned. This process leads to new procedures, better designs, and even safer skies for everyone. This ongoing cycle of learning and adaptation is what makes aviation safer with each passing year. New technologies, improved training, and updated protocols are constantly being introduced, all aimed at preventing accidents before they can happen. So the next time you board a plane, remember, you're surrounded by an invisible shield, built from decades of experience, innovation, and dedication. Every bolt, every checklist, every procedure is there to protect you. The real miracle isn't just that planes can fly, but that they do so with such extraordinary safety, making the sky not just a place of wonder, but a realm of everyday miracles. Two unsung heroes keep watch on every flight: TCAS and GPWS. TCAS scans the skies, tracking nearby aircraft and issuing direct commands to pilots if a collision risk arises. One climbs, the other descends. GPWS, meanwhile, protects from the ground below using terrain databases and sensors to warn if the plane gets too close to obstacles. Its urgent alerts like, "Pull up," demand instant action. These systems have made mid-air and terrain collisions exceedingly rare. They're not just alarms, they're active partners, guiding pilots through danger. Together, TCAS and GPWS form a silent, vigilant safety net. Most passengers never notice them, but they're always working to keep us safe. Fire is one of aviation's greatest fears, and for good reason. In the confined space of an aircraft, even a small fire can escalate rapidly, threatening everyone on board. The combination of high altitude, pressurized cabins, and flammable materials means that a fire emergency is a race against time. That's why the aviation industry treats fire prevention and response with the utmost seriousness. To combat this threat, planes are equipped with advanced detection and suppression systems designed to catch the earliest signs of trouble. These systems are meticulously maintained and regularly tested to ensure they work flawlessly when needed most. Smoke detectors in cargo holds are constantly on alert, scanning for even the faintest trace of smoke that could signal a hidden fire among baggage or cargo. Meanwhile, heat sensors in engines and other critical areas monitor for dangerous temperature spikes, instantly alerting pilots to any sign of overheating or fire risk. At the push of a button, powerful extinguishers flood affected areas with fire-suppressing agents, while systems automatically cut off fuel and power to stop fires fast and prevent them from spreading. If evacuation is needed, every door transforms into an emergency exit, equipped with inflatable slides that deploy in seconds, providing a rapid escape route from the aircraft. Before every flight, cabin crew meticulously arm the doors, ensuring that the slides are ready to deploy instantly if the situation demands it. Their pre-flight safety checks are a crucial part of keeping everyone safe. The goal is ambitious: evacuate everyone on board in just 90 seconds, even if half the exits are blocked by fire or debris. This standard pushes both design and training to their limits. This isn't just theory; manufacturers must prove it in real-life tests, with hundreds of volunteers scrambling out of a darkened, smoke-filled cabin under strict time limits. Crew are trained extensively to manage panicked passengers, direct them to the nearest usable exit, and keep order during the chaos of an emergency evacuation. They quickly assess which exits are safe to use, relying on features like illuminated floor lighting that guides passengers through smoke, and robust slides that can handle dozens of people in rapid succession. Every detail, from the placement of emergency equipment to the materials used in cabin interiors, is engineered for speed, efficiency, and survival in the worst-case scenario. In the end, it's all about getting everyone out, fast, safe, and alive. The systems, the training, and the design all work together to turn a moment of crisis into a story of survival. The yellow oxygen mask is a lifeline if cabin pressure drops. At cruising altitude, the air is too thin to breathe. Without oxygen, you'd lose consciousness in seconds. If pressure falls, sensors trigger the masks to drop automatically. Each mask is connected to a chemical generator, not a tank, producing oxygen for 12-15 minutes. That's enough time for pilots to descend to a safe altitude. The system is self-contained, reliable, and doesn't need aircraft power. Pilots have their own quick donning masks for emergencies. The slight burning smell, just the chemical reaction at work. This system bridges the critical minutes until normal breathing is possible again. It's a simple, brilliant safeguard for everyone on board. The secret to aviation's remarkable reliability is redundancy. Every critical system on a modern aircraft is designed with backups, often 2 or even 3 layers deep. This means that if one component fails, there's always another ready to take over, ensuring the safety of everyone on board. Redundancy isn't just a feature, it's a philosophy that guides every aspect of aircraft design and operation. Take flight controls, for example. They rely on multiple independent hydraulic systems, each capable of moving the control surfaces. If one system loses pressure or malfunctions, the others seamlessly take over, so pilots retain full control of the aircraft at all times. This layered approach is meticulously engineered and rigorously tested. The same principle applies to flight computers. Modern airliners are equipped with several computers that constantly cross-check each other's calculations. If one computer detects an error or inconsistency, the others can outvote it, instantly correcting the course and preventing a single glitch from escalating into a problem. Electrical power is another area where redundancy shines. Each engine has its own generator, and there's an auxiliary power unit, or APU, that can supply electricity if needed. In the rare event that all these sources fail, a deployable ram air turbine, or RAT, can be extended into the airstream to generate emergency power. The RAT, a small but vital propeller, spins in the wind and produces just enough electricity to keep the most essential systems running, like flight controls and communications, until the plane can land safely. It's a last line of defense, rarely needed but always ready. This philosophy of layered protection ensures that no single failure, no matter how unexpected, can bring down a plane. Every system is backed up, and those backups have backups of their own. Redundancy is woven into every layer of an aircraft, from the hydraulics that move the wings and rudder, to the electronics that guide navigation and communication. Even the wiring and plumbing are doubled up so a single fault can't compromise safety. This is why modern airliners are so robust, even when faced with severe weather, turbulence, or unexpected technical issues. Pilots are trained to handle failures calmly, knowing that the systems are designed to support them through any emergency. Backups for backups, that's the aviation way. It's a mindset that leaves nothing to chance, and it's constantly evolving as technology advances. This unwavering commitment to redundancy is the foundation of the industry's extraordinary safety record, making air travel one of the safest ways to journey across the globe. After an accident, investigators search for the black boxes, actually bright orange for visibility. Every airliner has 2, the Flight Data Recorder, FDR, and Cockpit Voice Recorder, CVR. The FDR logs thousands of flight parameters, creating a second-by-second record of the plane's performance. The CVR captures cockpit conversations and sounds, revealing the human side of events. These devices are built to survive extreme impacts, fire, and deep sea pressure. Each has a beacon that pings underwater for at least 30 days. Black boxes are the ultimate survivors, preserving vital clues for investigators. They turn tragedy into lessons that make flying safer for everyone. The loss of Air France 447 in 2009 showed why black boxes matter. The plane vanished over the Atlantic. The recorders were lost deep underwater for 2 years. When found, they revealed the pitot tubes had iced over, confusing the autopilot and pilots. The CVR showed the crew's confusion and failure to recognize a stall. These insights led to new training for pilots and better pitot tube designs. The tragedy became a catalyst for global safety improvements. The mystery was solved not by guesswork, but by hard data and audio evidence. Black boxes turned a disaster into a lesson that protects future flights. Asiana 214's 2013 crash in San Francisco was a wake-up call about automation. The plane came in too low and slow, hitting the seawall, despite perfect weather and a working aircraft. The FDR showed the pilots had inadvertently turned off the auto throttle and didn't notice the loss of speed. The CVR revealed confusion about the automation modes and a late call for a go-around. The accident wasn't mechanical, it was about human factors and automation management. Investigators recommended more training on manual flying and understanding automation. Airlines worldwide updated procedures to address these issues. The crash led to changes that help pilots better manage their sophisticated aircraft. Air travel's safety is no accident. It's the result of design, intention, and relentless improvement. From electronic guardians to physical safety systems, every detail is engineered and tested. The black boxes ensure lessons from tragedy are never lost. Stories like Air France 447 and Asiana 214 show how the industry learns and evolves. Training, technology, and global collaboration create a system of remarkable integrity. The most dangerous part of your journey is still the drive to the airport. Next time you fly, know you're protected by layers of technology and expertise. You're part of one of humanity's greatest success stories. The hum of the engines is the sound of reliability, redundancy, and a promise kept millions of times a day.